Good afternoon. First of all, let me introduce myself. My name is Volodymyr Plinskyi. I am a student of Kryviy National University. I am majoring in computer systems and networking. My research interests include energy consumption optimization in the IT sphere. And now I would like to present you the results of my research dealing with energy efficiency in IT in general and implementation of energy-saving technologies in networking in particular. So, I am going to speak about optimization of Internet Service Provider networking in the energy autonomous operational mode. As we know, development of our civilization is inseparably connected with energy consumption. In ancient times, people used the energy of wind, water and steam to improve living standards and shift from manual work to factory production. Nowadays, we use electric power as an energy source for our engines and machines. We even use electric power to talk to each other. It's a well-known fact that there is a direct dependency on a humanity development level on civilization energy consumption. So we should have enough power to move ahead. This slide demonstrates the increase in energy consumption within the period of 1800 to 2022. As you can see, this increase is tremendous. Over the last century, energy consumption has grown iteratively. According to the Thunderset Energy, global consumption of energy for the networking infrastructure is likely to grow by half in the coming 15 years. This chart shows energy consumption by networking infrastructure components with predicted energy demand increase to 5% of the global energy consumption in 2050. So, in view of the above, optimization of energy consumption in IT and implementation of energy-saving technologies are becoming increasingly actual. A certain energy deficit caused by growing demand adversely impacts the price aspect. Taking the United Kingdom as the example, we can see that this country faced a sharp rise in prices per kilowatt in 2022, and this trend persists at present in almost all countries. Rising the price of the final product if we consider the IT industry a market for goods and services. Thus, the energy price surge is another factor adding the urgency of implementing energy-saving technologies. Energy efficiency directly impacts the information system operation without replacing the backup power equipment. Autonomous operation time is a key factor for critical systems in conditions of unstable power supply. There are two ways to prolong autonomous operation time, namely to increase battery capacity and/or decrease power consumption. The Internet Service Provider infrastructure is one of such critical systems. Optimization of energy consumption is critical not only in terms of sustainable development of the global IT industry in the world, and first of all it is critical in conditions of Russia's war against Ukraine, then the aggressor targets the power supply infrastructure. Let's see what components of Internet Service Provider network require autonomous power supply. The network consists of servers, routers, aggregation switches, and final access equipment, last mile equipment. A complex approach to optimizing energy consumption in order to increase autonomous operation time of the Internet Service Provider infrastructure components involves finding separate solutions for each infrastructure component. The most common optimization solutions include transition to cloud technologies, replacement with more energy efficient equipment, implementation of more advanced technology. Optimization of the costs for server component energy consumption can be achieved through transition to cloud technologies, namely through virtualization, which is widely used nowadays. It allows placing a certain number of services on one physical computer in virtually separated spaces, instead of using physical machines for each of the services. Application of complex virtualization systems such as IBM, Proxmox, Xen, VMware enables reducing costs for information infrastructure, increasing failover, reducing costs for DevOps. For safety and security reasons, as well as due to legal requirements, access speed, and such, providers can keep the virtual servers in their power supply area or move them to third-party remote platforms with greater system stability. There are many companies that provide reliable virtual server hosting. Among the most famous are DigitalOcean, Microsoft Azure, Amazon, ColorBridge. Routers and aggregation switches cannot be moved out of their provider energy supply area, so energy autonomy enhancement is achieved by replacing the equipment with more energy efficient one or by replacing the backup power equipment with more capacious one. The service life of current equipment is 5–7 years. However, most manufacturers tend to keep market requirements as for energy efficiency and produce more efficient equipment. That is why it is reasonable to replace less efficient equipment much earlier. In addition, high electricity tariffs also make internet service providers try to reduce the energy consumption of the core or switching node by speeding up the planned replacement of equipment. Total benefit can come to 20–40%. The last but not the least issue in providing power reliability is energy autonomy of access level equipment. Most providers of fixed internet communication in Ukraine use the FTTB/FTTC technologies, wherefore up to 100% of crossover platform may need backup power. For this purpose, the mentioned technologies will soon be replaced with PON. This slide shows you that these abbreviations stand for FTTN, Fiber to the Node, FTTC, Fiber to the Curb, FTTB, Fiber to the Building, PON, Passive Optical Network. To compare the energy consumption of the network based on the FTTB technology and the PON technology, a small study has been conducted. In this table you can see the result of a study. The most common models equipment of Ukrainian providers' networks are chosen for comparison: the D-Link DES3526 switch and the BD-COM 3310 optical terminal. The user capacity of the FTTB-based equipment is 24 clients. The consumption is up to 23 watts per hour. The user capacity of the PON-based equipment is 256 clients. The consumption is up to 30 watts per hour. So, complete transition from FTTB to PON could replace more than 10 switches with one optical line terminal. 10 switches of the selected model consume up to 230 watts per hour, and 10 crossover platforms with backup power should be used. Simple comparison demonstrates that one optical line terminal consumes 6 times less energy than 10 switches. Summarizing the above, the following conclusion can be drawn. Power consumption of the server component can be reduced by 100% through virtualization and the use of third-party VPS/VDS services. Power consumption of the core and aggregate switching nodes can be reduced up to 40% through updating the model range. Power consumption of the last-mile equipment can be reduced six-fold through implementation of PON technology. I do hope what the described methods of achieving greater autonomy will find increasingly wide application. This will no doubt result in improved quality of services for the end user and an increase in the strategically reliable failover of communication channels throughout the country. Thank you for your attention.